Okay, in this video we're going to talk about how to solve an equation that's in the quadratic form. So it's not necessarily a quadratic equation, though it can be brought into the quadratic form by using what's called U substitution. Okay, so remember quadratic. So this was what quadratic form means. We want AU squared plus BU plus C equals 0, where A does not equal 0. Right? Reason why A can't be equal to 0 because then we wouldn't have U squared. So we're going to use U substitution to bring it into this quadratic form. Okay, so it's not X, but it's U. Alright, so let's go ahead and get started with this equation here. Notice, so let's see, I'm looking to do some sort of U substitution here. Now, so say I were to go ahead and set U equal to X to the 1/4 power. Then U squared would be X to the 1/4 power squared, right, which is the same thing as X to the 2/4 power, which is the same thing as X to the 1/2, okay? So that matches this term here. So this is U squared. This is U, okay? So here we have it. It's already in the quadratic form. Okay, so I'm going to go ahead and plug that in. So I'll have 2, instead of X to the 1/2 power, I'm going to use my U substitution, 2U squared minus U minus 1 equals 0. Okay, so now I can go and solve this by factoring the way I would normally do it. Okay, so the first thing when you're factoring, I always multiply the first and the last terms together. So 2 times -1 is -2. So then I find factors of -2. Okay, I make a little table and then I say the sum of those factors. Okay, and so factors of -2 are, for example, -1 and 2. -2 and 1, okay, and then find the sum of those factors. This one would be 1, sum of those two is -1. Okay, so we want the sum to equal whatever the middle term is, and that's -1. So we'll use these two factors here. Okay, so I'm going to go ahead and break this down. 2U squared minus, so I'm going to do -2U plus 1U, 1U minus 1 equals 0. Okay, so now I haven't changed between these two steps. I haven't changed anything, just kind of broke that U into 2 different pieces. Alright, so now I'm going to look at this side, see what I can factor out, look at that side, see what I can factor out. Looks like for the first part I can factor out both a 2 and a U. Alright, and then for the second part, nothing, I can't factor anything out. Alright, so now I can bring this term is now common in both sides, so I can factor that out. I'm going to factor it out over to the left, so I'll have U minus 1, and then what I'll be left with is 2U plus 1. Okay, so here's the 2U, and then there's a leading 1 out here, so 2U plus 1. Okay, so if you were to take this and then multiply by 2U, take this and then multiply by 1, what you'll get is this term up here. So I didn't change anything here. So this equals 0. So now I just need to, if either one of those terms, 2U plus 1 or U minus 1 were 0, the whole thing would be 0. So let's go ahead and solve those piece by piece. So I'll have 2U plus 1 equals 0, 2U equals -1, U equals -1/2. Okay, and then U minus 1 equals 0, U equals plus 1, right? I add 1 to both sides. Alright, but the goal was not to solve for U, right? I mean, that's part of what you need to do, but the goal ultimately is to solve for X. So I'm going to need to, plug in X in order to find what X equals. So, U equals 1/2, -1/2, so that means X to the 1/4, right? Because U equals X to the 1/4, so X to the 1/4 then also equals -1/2. Okay, so now if I were to bring both sides to the 4th power, I can solve for X. If I were to bring the 4th power, then the powers cancel, and this becomes just X, -1/2 to the 4th power. So X equals, so negative 1/2 to the 4th power. So if you multiply something an even number of times, it becomes positive again. So this is positive, and then 2 to the 4th power is 16. Okay, so 1/16. Right, then also same thing for u equals 1. We would do x to the 1/4 equals 1. Bring both sides to the 4th power, so x equals 1 to the 4th. 1 to the 4th is just 1. Okay? Okay, now it's really important, so we have both these answers. It's really important now at this point to check to see if there's any extraneous solutions, right? Or check that that your answers are correct. Remember, when you have rational exponents, especially things can happen, especially with the signs, and you can end up with an extraneous solution. Okay, so let's just check our answers. I'm going to go clear the page here. So our solutions were, x equals 1, and then also x equals 1/16. Okay, so let's do the check for both of these. So if I were to plug in x equals 1, I'll have 2 times 1 to the 1/2 power minus 1 to the 1/4 power minus 1 equals 0. So 1 to the 1/2 power, 1 to any power is just 1, so this is going to be 2. And then this one will be 1, this will be 1 equals 0. So 2 minus 2, basically. -1 minus -1 is -2. And so 0 equals 0, check. Alright, so now x equals 1/16. Let's check this one. So we'll have 2 to the 1/16 to the 1/2 power equals 1/16 to the 1/4 power minus 1 equals 0. Okay, to the 1/2 power basically is what? It's basically like the square root of 16. Okay, square root of 1 is just 1, so that's why I just left it as a 1 up there. And then this would be to the 4th root. Alright. Again, 4th root of 1 is just 1, so that's why I left the 1 up there. Otherwise, you have to take the 4th root of both the top and the bottom of the fraction. Okay? So, the square root of 16 is 4. The 4th root of 16 is 2, right? 2 times 2 is 4, and times 2 is 8, times another 2 is 16. So 2 to the 4th power is 16. Okay, so this minus 1 equals 0. Alright, so let's see. So 2/4, so we end up having 2/4 minus 1/2 minus 1 equals 0. 2/4 same as 1/2 minus 1/2 minus 1 equals 0. Okay, so 1/2 minus 1/2, those two cancel. So you end up with -1 equals 0. Alright, and that's not true, right? So this is an extraneous solution. So x equals 1/16 is an extraneous solution. So it is not a solution to the equation. So it's super important that you check your answers, especially when you have rational exponents, to make sure that your solutions are valid. So or are not extraneous solutions. So what's the solution set for this one? It's just 1. Okay, one more example. So this one, first thing that I'm going to need to do is put it into, so remember, we needed one side to equal 0, right? Because we're trying to get it into this format. A times u squared plus bu plus c equals 0, right? So I need the right-hand side to equal 0. So I'm going to subtract 15 square root of y from both sides. So I'm going to do that here. So subtract 15 square root of y. Okay, then plus 44, and then this side will not be 0 on. Okay, and then so I'm trying to see what u substitution is going to be appropriate here. So say I were to set u equal to y to the 1/2 power. Okay, so y to the 1/2 power, this is the same thing as square root of y. Same thing, right? So then u squared would equal just y. Okay, and that's great because, you know, this is this, right? And this is this. So, you know, we have it of the form. So instead of y, I'm going to write u squared. And then I'm going to have, oops, not plus, but minus 15y, or not y, 15u, right? 15u, right? Because square root of y is u, okay? And then plus 44 equals 0. Okay, so now I just need to factor this. You know, if I were to think of two things that you need to multiply together, and then you get 44, and then if you were to add them together, you get negative 15. You know, we say, oh, negative 11 and negative 4, right? If you add those two numbers together, you get negative 15. If you multiply them together, you get positive 44. Okay, of course you can always use the same factoring method that I used in the previous example, where you take 1 times 44, and then so that's basically 44, and then come up with 11 and 44 that way too. Okay, so this equals 0. So this side equals 0, or the other side equals 0. The whole thing will go to 0. So u, add 11 to both sides, so u equals 11, your u equals 4. Okay, so the goal is not to solve for u, goal is to solve for y. So I'm going to plug in the square root of y, because that's what u is. U is the square root of y. So I'm going to plug that in. And then I need to square both sides to solve for y. So y equals 121. And square root of y equals 4. So y equals 16. Okay. Those look like they could possibly be answers. Remember, it's super important to check your solutions. So let's do that now. Check to see if there's any extraneous solutions. So let's go ahead and plug in let's first check 121. So y is 121. So I'll say 121 plus 44 equals 15 times the square root of 121. So 121 plus 44 is 165. 15, square root of 121 is 11. 15 times 11 is 165. Okay, so check. So that's a valid answer. All right, then also let's check 16. So here we'll have 16 plus 44 equals 15 times the square root of 16, which is 4. Okay, and so 16 plus 44 is 60. 15 times 4 is also 60. So check. This is also a valid answer. So your solution set is 16 and 121.